Welcome to section 6.4, which is on arithmetic and other bases. So we've discussed already like what it means to, use a different base system, like if I were to do 6 base 8 or like 16 base 8 rather, something like that. Like if I just like start writing down some number and some different base, we've discussed what exactly does this mean, how do we interpret this number, but we haven't really done anything with it other than sort of relate this to our base 10 system. So think of different bases as sort of a different language. So when you're learning a new language, it can often be helpful to relate it to the language that you already know. But ideally, when you are like doing something with your language, like you want to like not have to translate back and forth between your other language all the times. And so if I wanted to add like two like base 8 numbers together, I would like to be able to add them without having to translate back to base 10, add them there, and then translate back to base 8. So let's think about how addition and subtraction and other operations work in our base 10 system that we're already comfortable with. Let's think about it a little bit more closely, because like we probably take a lot of the algorithm sort of for granted and kind of have lost sight of what actually like is going on under the hood. But examining like the details of those algorithms will inform us as to how we can take this to like other bases and make it work for those as well. Okay, so let's remind ourselves first how these operations work in base 10 and then relate that. Okay, so with like 217 plus 384, let's just do the standard algorithm. What most people would probably do here would just be line up the numbers here. So 7 plus 4, that's 11, right? So we would put a 1 right here and then carry the 1. Then we have 1 plus 1 plus 8, that's equal to 10. So we put the 0 here and then carry the 1. And then 2 plus 3 plus 1 is equal to 6, right? Under the hood, a little bit what's going on here is we're doing like 200 plus 300. We're doing 10 plus 80, and we're doing 7 plus 4, and we're adding all of these together and then adding those end results, right? 200, or let's go right to left here because that's kind of what happens in the algorithm. We do 7 plus 4, that is 11, right? We do 10 plus 8, or 10 plus 80, that's equal to 90. When we're carrying the 1, that means we're just regrouping a 10 over here. We're just borrowing this 10 and combining it with whatever happens over here. And then the 200 plus 300 is just 500. So like in the algorithm here, when we're carrying the 1, we could instead just write this as follows, just to make it a little bit more clear what's happening. 7 plus 4 is equal to 11. And then when we add this column here, we can really just do 10 plus 80, which is equal to 90. So just think of it that way. So 10 plus 80 is equal to 90. And then 200 plus 300 is equal to 500. And then just add these things up and you'll get to the same final answer. Okay. Before I do something similar to this, let me just kind of discuss a little bit like what okay. Let's say I wanted to add 5 base 6 plus 4 base 6. Okay, what is this equal to? So we could always just think of this in terms of just like counting up. So we discussed in the previous video, how do you count in base 6, and you'd go like 0, 1, 2, 3, 4, 5. And then once you can make a group of 6, then you say 1, 2, 3, 4, 5. After you can make a group of 6, then you say you have one group of 6 and then 0 groups of 1. And then one group of 6 and one group of 1. 1 and 2, 1 and 3, 1, 4, 1, 5 base 6, and then 2, 0 base 6, because at this point we have two groups of 6. So if I were to do 5 base 6 plus 4 base 6, I start with 5 and then I count up by 4. So if I'm at 5, I count up by 1 and now I make one group of 6, and then 1, 2, 3 more, I end up at 13 base 6. So just thinking of it in terms of counting, we can do that. So then if I wanted to do, let's say 8 base 12 plus 9 base 12, I could do a similar thing. 8 base 12 plus 9 base 12, counting in base 12, I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But instead of 10, we actually write the letter A, the symbol A, for the digit representing 10. And then the digit representing 11 would be B. And then after that comes one group of 12 and 0 groups of 1. And then 11, 12, 13. Let's see, how much have we counted up by? So we started at 8, and then we go 9, 10. Start at 8, and then we add 1, add 2, add 3, 4, 5, 6, 7, 8, 9. Okay, so we would get 15 base 12. But another way that you could think about this would be, well, if you were to think about, let me get rid of this. Okay, and then let's say that I wanted to add 8 plus 4, just in base 10, just normal base 10 addition. Or maybe let's do let's do 8 plus 9 in base 10. So you could think of this as start at 8 and then count up by 9, or you could do the make a 10 thinking strategy. So like if I borrow 2 from that 9, so split the 9 up as like 2 and 7, I could borrow that 2, combine it with the 8, and this gives me 10, and then I have 7 left over. So I have one group of 10 and then 7 left over, which gives me 17. I could do the same thing, but with base 12. If I wanted to borrow from the 9 base 12 to combine that with the 8 to make a 1, 0, which is just a one group of 12, I could borrow 4 from this. So split this up as 4 base 12 and 5 base 12. Writing TW for 12 here. And then 8 and 4, that adds up to 12, which is 1, 0 base 12 plus 5 base 12. So, and then one group of 12 plus 5 groups of 1 is just 1, 5 base 12, which is what we got before. Okay, cool. That's enough adding single-digit stuff. Let's talk about adding two-digit stuff. So if I wanted to add 1, 5 base 6 plus 5, 4 base 6, let's think about this in the algorithm here. So, so we can do it this way. So obviously you're going to be needing to be like comfortable with like the one-digit addition here. So let's maybe off to the side, you could do 5 base 6 plus 4 base 6. And again, you could either think of this in terms of counting, or you could do the make a group of 6 thing. So in base 6, we want to think of this as like one group of 6 plus some number of groups of 1 or whatever. So I could borrow 1 from the 4, like split that 4 up as 1 and 3, and then 5 base 6 plus 1 base 6 equals 1, 0 base 6. So that's 13 base 6. Okay, so 5 and 4 gives us 13 base 6. And then 1 and 5 What's 1 plus 5 base 6? Well, it's just 10 base 6. And then I'll bring down another 0 because we're really doing like 10 plus 50 base 6. If you wanted to, you could also, of course, record this same information by like carrying the 1. 5 base 6 plus 4 base 6 is 13 base 6. So I put a 3 right here and then carry the 1. And then if I wanted to do, oh gosh, sorry. Wait, no, sorry, I'm fine. Okay, now if I wanted to do this sum right here, 1 and 1 and 5, what does that make? Well, I'm doing a base 6. So 1 and 5 makes one group of 6. And then we have 1 left over, so that's 1, 1 base 6. Okay, so we should get 113 base 6 or 113 base 6. And then if I do that over here, adding these things up as well, I have one group of 6 squared, and then one group of 6, and then 3 left over. So 113 base 6 is our final answer. We could do this with larger numbers as well. So 253 base 6 plus 334 base 6. And the math is going to work out just the same. It just ends up being a little bit longer. So if you are kind of feeling comfortable, maybe pause the video and try this on your own. You'll have to do stuff like 3 plus 4 base 6, 5 plus 3 base 6, 2 plus 3 base 6, and think about carrying, when do you make groups of 6, and so on. I think it's a good exercise to try this right now if you have not already. So I'll give you a second to pause. Okay, that's the second. I'm going to move on. So let's do this. So I'm going to not do as much stuff to the side here. I'm just going to maybe discuss it out loud. So what's 3 plus 4 base 6? Well, I could split the 3 up as like a 2 and a 1. 2 plus 1, and then the 2 and the 4 combines to make a 10, and then I have 1 left over. So 10, and then 1 left over, I'll write that as 11. Okay. Maybe I'll carry the 1 actually. All right, 1 and 5, and then a 3. So 1 and the 5 are going to make a 6, and then we're going to have another 3. So I have one group of 6 that's going to be represented by carrying the 1. And then that extra 3 right there. And then I have 1 plus 2 plus 3. Base 6, counting that up, that's equal to 6, which I would write as 1, 0, base 6. So 1031 base 6 would be our final answer. Base 12, okay. Everyone's favorite. So this is gonna be a little trippy because you have to, I don't know. I think that adding in like base 12 is like harder than adding in like base 6 for some reason. I think it's just the fact that like there's more digits than we're used to just makes it like a little bit harder. But anyway, let's think about it. So 5 plus 9 in base 12. What would 5 plus 9 base 12 be? Well, I could take 3 away from the 5, split this up as like 2 and 3. And then if I take the 3 and then combine it with the 9, that makes one group of 12 with 2 left over. So that's equal to 1, 2 base 12. Okay. And then I'll represent the 1, 2 base 12 by carrying this 1 up here. 1, A, and 5. What does that give me? So A represents 10. So 1 plus A is equal to like 11 in our base 10 system, right? But we're thinking about this in base 12. So in base 12, 1 plus A is equal to B, right? Because B is the digit that represents 11 in the base 12 system. And then I'm going to add 5 to this. So if I'm trying to make groups of 12, I could pull a 1 away from this 5 right here, split this up as like 1 and 4. And then I have a 1 here, a 1 here, and a 10 here, and then 4 left over. So 1, 10, and 1 makes a 12, and then 4 left over. Get 4, and then a 1. All right, what's 1 plus 9 plus 1? Well, in base 10, that would be 11, but the digit that represents 11 in base 12 would be B, so we'll just put a B here. There's no carrying to be done. What's 6 plus B? 6 plus B, I could pull 1 apart from the 6 and be left with 5, because this is 11, so 11 and 1 is going to make a group of 12. So I'll have one group of 12 and then 5 left over. So 1, 5, base 12. It's good to every now and then maybe do like a reality check. 6 plus B, base 12. B represents 11. So 6 plus 11 in our base 10 system would be 17. But if you were to convert 17 into base 12, 17 would be like one group of 12 and 5 left over, 12 plus 5. So one group of 12 and 5 left over in base 12 system would just look like 1, 5. So good reality check to just sort of confirm that we're doing this right. So 1, 5, B42 is our final answer. Cool. Let's move on to subtraction. So in base 10, what would this subtraction problem kind of look like? So there's like a ton of different ways that you could think about subtraction. I'm just going to talk about it in the standard algorithm that we discuss usually. Okay. So I have 0 ones right here, and I'm trying to take away 3 ones, right? I can't take 3 away from 0, so I have to borrow a group of 10 from this next larger place value, and then do that over here. Or combine that over there. So if I borrow a 10 from whatever is in my tens place, I drop down the number of tens that I have by 1, and then this now increases to one group of 10 and then 0 groups of 1, or plus whatever is going on here. And now I can just subtract 10 minus 3, which is 10 minus 3. You can just kind of count down, which we're going to probably have to do that a lot when we're doing other bases. So count down by 3, and you get to 7. Same thing over here. 0 can't take away 9, so I have to borrow the next place value up, borrow a group of 10. It's really borrowing a group of hundreds. Borrowing a group of hundreds here. So we have 400 left, and then 100 gets combined over here. And then I take away 9 groups of 10 from this 10 groups of 10. And I'm left with one group of 10, 10 minus 9, which again, counting down by 1. And then 4 minus 2 is 2. Right. So let's do this in base 5 now. So 4, 1, 0 minus 1, 2, 3 base 5. So I have 0 ones and then 3 ones, and I'm taking those away, right? So if I want to subtract, I'm going to need to borrow here. So I need to borrow this group of 5, right? This is our 5's place. This is our 5 squared place. This would be our 5 to the 3rd place, and so on. So I'm borrowing a group of not 10 here, but 5, which, in base 5 is 1, 0 base 5. That would be 5 base 10, right? So I'm borrowing one of these. And then I'm making that into a 1, 0 base 5. Okay, so I borrow this, bumps that up to this. Okay, now what is 1, 0 base 5 minus 3 base 5? Well, 1, 0 base 5, what comes before that if I'm counting in base 5? Well, counting up in base 5, I would go 1, 2, 3, 4, and then I get to one group of 5, and then I get 1, 0 base 5. So if I want to count down by 3, I go down 10, 4, 3, 2, I get 10 minus 3 is equal to 2 in base 5. All right, 0 minus 2. I need to borrow from here. So this goes down by 1. And then I borrow that one group of 5 over here. So now I have one group of 5, and then I take away 2. If I have one group of 5 and I take away 2, I am left with 3 groups of 1. You could do that by counting down as well, or you could just intuitively think, if I need to make one group of 5, what plus 5 is equal to 2? 3. All right, 3, take away 1, I just get 2. Nothing special going on there. All right, let's see if you could do the following one. This is 410 base 6 minus 124 base 6. Pause the video and give it a shot and see if you get the same answer as me. By the way, I like writing the base 6 over here, not because it makes the problem more correct in any substantial way, but it reminds me what base we're working in. So I think writing this here, even though it seems unnecessary, I think it's kind of helpful just to have that as like a check. Like if I like wrote down just answers over here without the context that this was base 6, if I were to look back at this, it would be like really confusing. Or even if I'm just in the middle of the problem and I just kind of forget what base I'm working with, that would actually happen to me sometimes. It's just nice to kind of have that there. So 0 take away 4, I need to borrow. So I'll borrow from the tens place, or the groups of 6 place, and that'll make 1 group of 6 and 0 groups of 1. 1 group of 6 up here, take away 4, and I'm left with 2, because 2 and 4 make 1 group of 6, which is 10 base 6. 0, take away 2, I need to borrow, so let's borrow here. Now I have 10 base 6, take away 2 base 6. So 1 group of 6 minus 2 leaves me with 4 groups of 1. 3 groups of 1 minus 1 group of 1 is 2. Okay. Let me maybe do like one more example here. I'm kind of ad-libbing here, but I kind of just want to do one more example where the borrow, because I feel like all of the examples we've had with borrowing have just been having like subtracting 10 minus something. So let's do something slightly different. Let's do maybe a base 12 problem. Let's do 1, 2, 3 base 12 minus 56 base 12. So this will be like a little bit harder, but I think it'll be valuable ultimately. So we start by taking 6 away from the 3, and to do that we'll need to borrow. So I borrow from here, and that makes 1 group of 10 and 3 groups of 1. 1 group of 10 and 3 groups of 1, take away 6, what do I get? Well, all right, so if I were doing 13 minus 6 and just like base 10, so obviously this will be 7. Hopefully that's obvious to you. But yeah, so one way that you could kind of think about this, or like help someone who's learning how to do these problems for the first time, like how would you explain this to a kid, right? One thing that you could kind of do would be, well, take away 3 first to get to 10, and then count another 3 down. So that gets me to 10, and then take away another 3, and then just count down from 10. Or just think, 3 plus what gives me 10, and that would be 7. So we could do the same thing over here. So 3 base 12 minus 6 base 12. That's like 13 minus 3 minus another 3. So 1, 0 base 12 minus 3 base 12. And then counting down from 1, 0 base 12, which is one group of 12 and 0 groups of 1. Counting down from there, we go a group of 12, a group of 11, a group of 10, a group of 9. Or you could just think 3 plus what gives me one group of 12. 3 plus 9 gives me one group of 12. So we'll put a 9 right here. Okay, 1 minus 5, need to borrow. And then 1, 1 base 12 minus 5. So 1, 1 minus 5, I can first take away 1, and then take away 4. So if I take away 1, 11 minus 1 is 10. And then if I want to take away another 4, this is base 12, I have one group of 12, and then I'm taking away 4. One group of 12, take away 4, I'm left with 8, because 12 minus 4 is 8 in base 10. Okay. Yeah, so you get 89 base 12. All right, on to multiplication. 36 times 24. I quite like this trick, the rectangle visualization trick. I think it's very useful for understanding visually like what's going on. So on the top you have 30 and 6, and on the side you'll have 20 and 4. So this side length is 24, this side length is 36. And then I split this up according to like place value. 24 is broken up into your tens place and your ones place, and then similar for 36. Then you just have to multiply, like find all of these 4 areas by multiplying 30 times 20, that's 600. 6 times 20, that's 120. 30 times 4, that's also 120. 6 times 4, that's 24. You pay attention to the zeros that are showing up here, like the 6 and the 20 makes 120. I think this like kind of helps a lot as far as making sense of it. You could of course do the standard algorithm. There's the standard algorithm. You do 6 times 4, that's 24, and then you do 3 times 4, that's 12. 12 plus 2 is 14. So then you do that, and then you forget about all the carrying, and then go on to 36 times the 2. 6 times 2 is, and we put a 0 there too. Why do we put a 0? Think about it. I'm not going to say it, but see if you understand why we put the 0 there. Or I'll just tell you. It's because we're multiplying 36 times 20. There's an implicit 0 there, so multiplying by 20, we're going to have this extra 0 there because it's like 36 times 2 times 10. So we put a 0. All right, 6 times 2 is 12. Carry the 1. 3 times 2 is 6, plus the 1, 7. So we should get 864. There's not any carrying to do with the addition, but if we had like, this was like a 4 and a 9, then we would obviously like have to like carry a 1 when we add all this stuff up. There's another way of doing this that more closely mimics what's going on up here. So we do 6 times 4 is 24. We don't carry anything. We then do 3 times 4, but think of it as 30 times 4. So we'll put an extra 0 there because it's really like 30 times 4. 3 times 4 is 12 though. Then we'll do 6 times 2, which is 12, but I'll put a 0 there because it's really 6 times 20. So 12 or 120. And then 3 times 2, but we'll have 2 zeros. So 2 zeros, and then 3 times 2 is 6. Add all this stuff up, and then you again get to 864, which would be the same thing if you were to do this method, and then just add 600, that. That's literally what's going on in this computation. All right, 23 times 3. So 23 base 4 times 3 base 4 is what? So we have to do first 3 times 3 base 4. Okay, so maybe you're squinting your eyes and thinking, well, what the heck is 3 times 3? Well, in base 10, 3 times 3 is the same as 3 plus 3 plus 3. So you could either think of this as, well, add 3 plus 3 first, and then add another 3. Or you can think of it as like counting by threes. So counting up, I would get 3, then 6, then 9. You're like still like kind of doing repeated addition here, but however you want to think about it, just go with it. Okay, so 3 times 3 base 4. So if I were to count in base 4, so 0, 1, 2, 3, and then one group of 10, one group of 4, and then one group of 4 and one group of 1, and then 1, 2 base 4, and then 1, 3 base 4, and then 2, 0 base 4, 2, 1 base 4, 2, 2, 2, 3. That's kind of what our counting table would sort of look like. So 3 times 3, I can count by threes. So start with 3, and then 1, 2, 3 more, and then 1, 2, 3 more. So that should be equal to 2, 1 base 4. If you wanted to think about this in terms of repeated addition, 3 base 4 plus 3 base 4 plus 3 base 4. What's 3 plus 3 base 4? Well, I could borrow 1 from the 2 to make, 3 plus 1 is equal to 1 group of 4. 1 group of 4 with 2 left over is 1, 2 base 4. Okay. And then 1, 2 base 4 plus another 3 base 4. I want to borrow from this to make, to combine with this to make a group of 4. What can I borrow from this to make a group of 4? Well, I can borrow 2 from this, be left with 1 left over. And then, because the 1, 2 base 4 is really 1, 0 plus 2 base 4. And then the 2 and the 2 will make another group of 4. So we have 1 group of 4 here, 1 group of 4 here, and then 1 left over. So that's equal to 21, or 2, 1 base 4. So 3 times 3 base 4 is equal to 2, 1 base 4. And then what's 2 times 3 base 4? So you could just do that as like 3 plus 3, which is equal to 1, 2 base 4. So I'll just scan that down because that's going to be your answer. And then tack on a 0 here because we're really doing 2, 0 times 3. So like whenever I have like an extra like 0 over there, it's going to just put an extra 0 in the place value there. But maybe as an aside, you could also think of this as like repeatedly multiplying by, repeatedly adding 2. So 2 times 3 base 4 is 2 plus 2 plus 2 base 4. 2 plus 2 makes 2 and 2 makes 1 group of 4, so 1, 0 base 4. And then 1, 0 base 4 plus 2 base 4 is just 1, 2 base 4. So this confirms that we should get 1, 2 base 4. All right. Now, if I add this up, common mistake that I would see people do would be the following. What is wrong with this? Think about it. Maybe take a second to think about what's wrong with this. Hopefully you notice the 4 is what's wrong with it. 4 is not a valid digit in base 4. We can only use the digits 0 through 3, like we have over here. So whenever I have like a group of 4 there, I have to carry. So I make a group of 4, and then I carry. So this is like, 1, 0 base 4, and then I'll carry the 1, and then 1 plus 1 is 2. So this would be 2, 0, 1 base 4. With numbers this small, you could also do just 2, 3 base 4 plus 2, 3 base 4. Add that up, and then get that answer, and then add another 2, 3 base 4. If you were to do this, 3 plus 3 base 4, that's equal to 1, 2. I could carry that 1 if I wanted. And then 1 and 2 makes one group of 4 and then 1 left over. So 1, 1, base 2. And then I'll add that remaining 2, 3, base 4. 2 and 3 makes 1, 1. One group of 1 and then one group of 4, which I'll carry. And then 1 and 2 makes not 4, but 1, 0, base 4. I'll carry that 1. And then we get 201 base 4, which again just confirms our answer of 201 base 4. All right, cool. Let's do a slightly harder one. So 4, 3, base 6 times 3, 5, base 6. If you're feeling confident, maybe you could pause and try this one. If you're not, feel free to just continue to watch and learn. Okay. So 4, 3 times 3, 5, all in base 6. So 3 times 5, base 6. What would that be? So it's probably... Okay, I'm pretty sure it's going to be 2, 3, base 6. Counting off in 3s in base 6 is actually like pretty easy. So, oops. All right, so in the same way that like counting by 5s in base 10, 5, 10, 15, 20, 25, 30, because like 5 is half of a group of 10. Every 2 times that you count up by 5s, like you go up by a group of 10, right? And then you have like one group of 10, and 2 5s later, you're at 2 groups of 10, so on and so forth. Same thing with like 3s in base 6 or 4s in base 8. If it's like half of your base, then counting off by that. So you go 3, and then 3 plus another 3 makes a group of 6. So 1, 0. And then plus another 3, you're at a group of 6, and then 3. And then another 3, you're at 2 groups of 6. And then 2, 3, and then 3 groups of 6. And then 3, 3, and then 4 groups of 6, and then 5 groups of 6. And then 6 groups of 6, which we would really say one group of 36 or 6 squared. And you just kind of keep counting off like that. You could also do this. Okay, so what's our answer here? It's going to be 2, 3, because you go 3, 1, 0, 1, 3, 2, 0, 2, 3. So it should be 2, 3, base 6. If you wanted to count off by 5s, it still works out. You just do 5 plus 5, which equals 1, 4, plus 5, which equals 2, 3. So you get the same answer. Either way is fine. Many ways of thinking about these things. So 3 times 5 is equal to 23, base 6, or 2, 3, base 6. What is 4 times 5? Well, 3 times 5 is 2, 3. So 4 times 5, we could actually just kind of leverage this information, because this is the same as 3 groups of 5. If I wanted to do 4 groups of 5, I just take this thing and then add 5 to it, because this is already 3 groups of 5. And if I add one more 5 to it, that's going to be 4 groups of 5. So 2, 3 plus 5. Well, I want to take something away from this 5, combine it with this to make a group of 6. So I can combine, so this is like 3 and 2. So borrow the 3, combine that with that 3, and then I make another group of 6, which I'll increment that by 1. So that's 3 groups of 6, and then plus the 2 left over. So 3, 2, base 6. So 4 times 5 is 3, 2, base 6. 4 times 5 is 3, 2, base 6. I'll put a 0 there, because this is like 4, 0 times 5. Okay. What is 3 times 3? It's the next thing we do. So again, 3, one group of 6, 1, 3. Same pattern. I'll put a 0 there because it's 3 times 3, 0. Now 4 times 3, that is going to be 2, 0 base 6. Because that's going to be 3, one group of 6. 1, 3, two groups of 6. And then careful with the number of zeros here. So this is like 4, 0 times 3, 0. So I do 2 extra zeros here, and then the answer goes there, which would be 2, 0. So we, as a result, end up with 3 zeros at the end. Okay. Now, again, we add up all of the columns, just doing it, using base 6 addition. 3 is the only number in this column. 2 plus 2 plus 3. So, base 10, that would be 7. So let's make a group of 6. 3 and 2 makes 5. 5 and 2, I can borrow a 1 from the 2 to make a group of 6, and then I'm left with 1 left over. So 1 group of 6 and then 1 left over. I'll carry that 1. Carry that 1 group of 6. And then 1 plus 3 plus 1 is equal to 5. And then bring that into 2. So 2, 5, 1, 3 base 6 is our answer. Oh, I didn't show this thing over here, which I specifically wanted to do this. Hinted at it earlier in the video too. I see a lot of people really like the box thing too, of you could just do 40 and 3 and then 30 and 5. And then you'll still need to kind of do like the 1-digit multiplication off to the side here. So you'll do like still have to do 4 times 3 is 2, 0 base 6. So that's 2, 0. And then because this is 4, 0 times 3, 0, I include the 2 extra zeros here. And then 3 times 3, 0 base 6, that's 1, 3. But then I put down the extra 0. 4, 0 times 5 is 3, 2. But include the other 0, and then 3 times 5 is 2, 3 base 6. And then you just add up all of these numbers, just like we did over here, and get to your same final answer. 405 times 35 base 12. I specifically want to do this one with the box, so I'm going to do it. If you have not attempted one of these problems on your own yet, I'll get you set up with the box, and then please pause the video and try it on your own before seeing what I do. Okay, so this is all base 12. So base 12 multiplication, again, can be like a little bit tricky. So what's 4 times 3? Well, 4 plus 4 is equal to 8. And then 8 plus 4 is equal to 1 group of 12. So 1 group of 12 would literally just be written as 1, 0 base 12. Okay, so we get 1, 0 base 12. And then because this is like 400 times 300, I'm going to have 3 extra zeros here. Okay, 5 times 3, what is that? So 5 plus 5, I'll think of this as repeated addition. So I want to make a group of 12. So here I have like 10, and then I want to split this like remaining 5 up as like 2 and a 3. So I can combine this 2 with this 10. By the way, if I wanted to write this in more steps, this would be like a plus 2 plus 3 if I'm doing like the base 12 digits. And then the a and the 2 are going to combine to make one group of 12 and then 3 left over. So this would be 1, 3 base not 6, 12. So this would be 1, 3. Wait, sorry. 3 times 5, that goes up here. So 1, 3, 0. 4 times 5. Yeah, so up here we have 3 groups of 5. I want 4 groups of 5. So that's going to be 3 groups of 5 plus another 5. And then that's just going to be 1, 8 base 12, because I just have to combine the 5 with the 3. All right. Can actually leverage that that information right here as well, because 5 groups of 5 compared to 4 groups of 5, well, this is just one more group of 5. So 1, 8 base 12 plus another 5 base 12. Sorry, my handwriting at the subscripts is terrible right now, but whatever. Okay, so 1, 8 plus 5 base 12. So the 8 and the 5 would make 13, which is bigger than 12. So I want to make a group of 12. So I'm going to split the 5 up as 4 and 1. Combine the 4 with the 8 to make a group of 12. Now I have 2 groups of 12, and then the 1 left over. So 2, 1 base 12. Okay, so 5 times 5 is 2, 1 base 12. And then 4 times 5 we said was 1, 8 base 12. And then I'm putting the zeros there because this is 400. All right, now I line everything up. And simply add. So 1, this will be a 5, this is a 9, this is a 1, this is a 1. Luckily, we didn't have to really do anything weird with the base 12 addition here. Like there's not like any even like A's or B's here, but sometimes you might get an answer that looks like 2B 5 6 or something like that. If you have like, if this was like a 5 plus 8 plus 1, then you would have to like make a group of 12 and carry the group of 12 over. So 5 plus 8 plus 1 would be like 14, which is like one group of 12 and then 2 left over. So you'd have a 2 down here and then you'd carry the 1, etc., etc. All right, to finish out the video, we're not going to do a lot with division. So this is really just like kind of bonus material. It's covered in the book, and I think that it should kind of be here just for completion. For some reason, it's not in the homework, probably just because the other 3 operations by themselves are just kind of a lot already. Like the stuff is kind of hard, honestly. So yeah, maybe just doesn't have to be thrown on your plate if you don't need it. I won't be testing on it because it's not on the homework, but this is here just in case you were kind of curious. In terms of just like regular old division, so 123, wait, where did, oh yeah, somehow I skipped a slide. So if I wanted to do 45 divided by 3, if I were to just do like my regular old division, I could think of this as like, how many times does 3 go into 40? So how many times does 3 go into 40? Well, it goes in 10 times, right? And 10 times 3, that's equal to 30. So if I take, if I take 10 groups of 3 away from 40, I'm left with 10. And so that is reflected over here. I do, how many times does 3 go into 40, ignoring all of the digits to the right of the 4. And it would go in 10 times. And then you get 30, take that away, and you're left with, now subtracting this down, I get actually 15. And then how many times does 3 go into 15? Well, it goes in 5 times. 3 times 5 is 15, so take that away, and then we don't end up having any remainder here, so you can add up all of these things together and you get 15. Normally when you're doing it this way, you don't really need to like stack all the zeros and stuff like that. You can just kind of abbreviate a lot of notation by getting rid of like a lot of those zeros, but in terms of trying to understand what's going on, maybe that's more beneficial. All right. So over to like the base 6 problem. 123 base 6 divided by 3 base 6. Well, how many times does 3 go into like 1 base 6? Well, it doesn't go into 1 base 6 at all, so we'll just skip that and then move on to how many times does 3 go into 1 2 base 6. So you kind of have to understand multiplication a little bit here. So 3 base 6 doubled gives you 1 group of 6, and then tripled gives you 1 group of 6 and 3 groups of 1, and then quadrupled you get 2 groups of 6, and so on. So obviously we have to stop before we pass 1 2 base 6, so we're just going to put a 2 right here. 2 times 3 base 6 is 1 0 base 6. Subtract that, I get a 2, I carry this 3 down, and I get 2 3 base 6. Okay. 3 times what is equal to 2 3 base 6. Again, we can count off by 3s. 3, 1 group of 6. 1 3, 2 groups of 6. 2 3, and then, well, we're looking for 3 times what gives me 2 3 base 6. Well, 1 2 3 4 5. So 25 base 6. That would be your quotient. Okay, and yeah, so I think that's the video. Thank you for listening. Hope that you found this valuable. This stuff honestly is quite complicated. I know it's like very hard for students. I've taught this like a couple of times, and no matter like how much time you spend on it, you can kind of, it is kind of like learning a new language. It's not super easy, but it comes with time, it comes with patience, and you will get it. So anyway, see you in the next one.